In this video, we will look at temperature changes during a simple experiment and go and look at the required practical to do with temperature changes. The video it will talk about some of the equations, and hopefully we'll generate some data and we'll look at how this can be used graphically and how we can go and evaluate it.
The first thing that we really need to think about when thinking about temperature changes in reactions is what happens during exothermic reactions. So when a chemical reaction happens, energy is transferred to or from its surroundings. When energy is transferred to its surroundings, it is called an exothermic reaction. The energy of the product is less than that of the reactant, so therefore heat is given out. So examples of this include combustion reactions or neutralisation reactions. Just a reminder, a neutralisation reaction is where you go and react two chemicals together, usually a acid and a base. An example would be a metal hydroxide plus an acid would go make a metal salt plus water. A salt and water are produced when an acid reacts with metal hydroxides. A salt and water are produced because the hydrogen ion in the acid will go and react with the hydroxide ion in the metal, so therefore would make water, and what would be left over would be a metal salt. So an example of this would be where we react sodium hydroxide with hydrochloric acid, and that would make sodium chloride plus water. If we're going to go and look at this practically, we would start off by measuring out a specific amount of hydrochloric acid and putting that into a beaker. So we might measure out 50 milliliters of hydrochloric acid with a measuring cylinder. You would then go and take the initial temperature of that hydrochloric acid because we want to go and look at the temperature change. Start off by reacting 10 milliliters of sodium hydroxide with the acid. Stir it for about 30 seconds and then retake the temperature. The difference between that temperature and the temperature before will be the temperature change. Repeat this process with 20, 30, 40 and 50 milliliters of sodium hydroxide, calculating the temperature change each time. Once you've run through the entire practical, you would preferably go and repeat it another 3 times so that you had 3 sets of results. So, when looking at this practical, we need to think, what is the independent variable? So the independent variable is what we're changing. So we are changing the volume of sodium hydroxide. What is the dependent variable? The dependent variable is what we're measuring. So therefore the dependent variable is the temperature change. What are we looking for in this investigation? So we're looking to see at how adding different volumes of sodium hydroxide to a set amount of hydrochloric acid affects the reaction, so therefore affects the temperature change that we see. Some of the control variables. The main one is making sure that we keep the same amount of acid each time. And finally, how many times would we repeat it? We would repeat it 3 times so that we can prove that our results are reproducible. The following short clip will run through how this practical can be carried out in the lab.
So, in this short bit of video, we're going to look at how we can go and look at temperature changes within the experiment. So, we'll start off by going and measuring out 50 millilitres of sulfuric acid using a measuring cylinder. We then would go and pour that in. Next, you would go and take an initial temperature for what it is, so that would be 18.3, because we want to see what the temperature change is going to be. Finally, you'd go and measure out, so we'll do this with 10 millilitres of sodium hydroxide. You would then go and measure that out with another measuring cylinder, pour it in, and stir. So, this reaction should produce some heat. So, we can see that it's gone up to 21.5. So the change in temperature would be 3 degrees. If you were carrying this experiment out for yourself, you would then use different volumes of sodium hydroxide. You would also repeat the entire experiment 3 times to ensure that your results are reliable and to give you enough data to go and get yourself a mean. It would also demonstrate that the results were reproducible.
So, once we have run through this experiment in total, we might end up with a set of results that look something like this. There are a number of things that we need to think about when looking at these results. The first thing is, what is the pattern in the results? So we can see that as the volume of sodium hydroxide added is increased, the temperature change in the reaction also increases. There is a positive correlation between the volume of sodium hydroxide added and the temperature change. If we're thinking about the range of sodium hydroxide used, the range is between 10 centimetre cubed and 50 centimetre cubed. We've repeated the experiment more than once, and that shows that the results, because they're all relatively close to each other between the first and second trial, that shows that the results are reproducible and are reliable. How could we improve the precision? Right, if we were improving the precision, you need to look at using something like a digital thermometer that goes and measures the temperature change to a greater number of decimal places. If we went and put our results onto a graph, they might look something like this. So one question that we might want to think about is, what volume should we use if we want a temperature change of 5 degrees? The answer, you would go and read across from 25 degrees, then read down to the volume of sodium hydroxide, so that would give us an answer of 24 millilitres.
So, hopefully that should cover everything that we need to know about the temperature change required practical. If you have any further questions, leave a comment below and I will endeavour to get back to you.